I'd love to invite our speakers on stage already. Hi everyone. We're very excited that you're able to join us tonight. I'm Jonas and this is Katja, and tonight we will be your moderators. We are students, part of the Maastricht University iGEM team of 2025, and in collaboration with OmniUm, we decided to organize this debate on the role of GMOs in society. So a little bit more about who we are and what we do. iGEM is an international university-level research competition on basically trying to solve real-world problems using synthetic biology. If you haven't heard that term before, synthetic biology, or synbio, is a discipline which tries to combine techniques and ideas from biology, chemistry, and engineering in order to design, create, and modify living organisms or systems. So basically genetic engineering, and that's what we're here to discuss today. So synthetic biology is, in and of itself, kind of a subversion of natural processes, because we are literally creating and changing life. Now this is nothing new, but humanity has progressed from using agricultural selective breeding to where we are now, where we can work with the smallest units of life with kind of staggering accuracy, and basically change the genetic makeup of organisms in real time. And we're talking about a field which is still in its infancy, but which has the potential to drastically change our way of life, and whose applications are practically limitless.
So in our own research, we introduced genetic material that we have designed into organisms as a way of reprogramming them. This means that as iGEM participants, we work with and make GMOs every single day. This is a lot of responsibility, especially as students and future scientists. We understand that we do not have a completely neutral perspective on GMOs, seeing as we work with them every day. However, we do try and integrate a holistic overview on how our research impacts people and enlarge the public. There are many questions that we ask ourselves. Is something that is made with synthetic biology considered biological or natural, even though it arises completely artificially? Does the creation even deserve to exist? And does the scientist who made it, did he deserve to make it?
So today we aim not to glorify synthetic biology, but to offer a wide range of perspectives on genetic engineering and bio. We want to be able to provide a platform for a discussion about GMOs, because they're very important, and because we consider it very important that you, our audience, engages with this technology in a critical and informed way.
This event will be split into 3 parts. So the first part will be a debate between the panelists based on prompts that they've received. Then we will have a short recess for drinks, and then the second part will be a Q&A between you, the audience, and the speakers. We ask that you listen with an open mind, and when asking questions, please do so with genuine curiosity and respect. We'd like to thank OmniUm, Job, and of course our panelists for making this event happen. We've chosen these panelists not only for their insight and knowledge, but because we'd like to portray a broad perspective of opinions. And then, to our panelists.
So from right to left, we are very excited to introduce to you Dr. Tjalling Sriestra, who is a professor of philosophy at Maastricht University and researches the ethics of new and emerging sciences and technologies. He was also elected to be a member of COGEM, which is the advisory organization that basically works with the Dutch government on how to implement and work with GMOs in relation to society. And we also invite you all to expand on yourself in a moment. Dr. Erik Steen-Redeker is our own iGEM supervisor. He is a professor at UM, and his main research interests are molecular biology, synthetic biology, and he mainly focuses on plastic degradation using bacteria. Yeah, and he is the one who started and continues the tradition of iGEM teams at MSP. Next up, we have Anirudh Rajesh, who is a recent graduate of Maastricht University and the CEO and co-founder of his own company, Estuarian, who started up as an iGEM team from Maastricht University in 2022. Next up, we have Massimiliano Simmons, who is also a professor of philosophy at Maastricht University. You may recognize him along with Telling because they also teach the philosophy of technology course at MSP. And he focuses on technoscience, such as synthetic biology, and views them through a sociological and historical lens. Last but not least, we have Nina Holland, who is a researcher and campaigner for Corporate Europe Observatory, which is a nonprofit organization that conducts research and campaigns against corporate lobbying power in the EU. And Nina focuses on agribusiness lobbying from pesticides to biotech. I would love to invite you all to talk a bit more about yourselves, maybe maximum 1 or 2 minutes. And if we could start with Charlie, that would be great. You have a microphone on the table.
Yeah, stall a bit. Yes, well, it's first of all, it's great to see that so many of you turn up, so that there is a real genuine interest for this topic. The topic has been with me for, I think I started my career in biotech and philosophy with the debate on Dolly, the cloned sheep, and since then there are lots of different hypes and let's say instances of biotech. And what's interesting is that you see the same themes reoccur over and over again. So I'm looking forward for tonight and seeing whether we can make some progress.
Okay. Hello. Yeah. Okay, so my name is Erik Steen-Redeker. As said, I work at the Maastricht Science Program, where I teach and do research mainly in the synthetic biology area, but I'm actually a chemist shifting into molecular biology. One of my projects, like you say, is plastic degradation, so using yeast and bacteria that eat plastics. But it's actually not, it's one of my long-term projects, but it's not my only project. So, but my main research focuses on using synthetic biology to solve those environmental questions or health questions, and see if we can use biology to make the world a little bit better. But I'm a little bit biased also because I'm doing synthetic biology on a daily basis, so that's probably why I'm in the team. So we're in the panel.
Can you hear me? Yes. Cool. Hi, I'm Anirudh, co-founder and CEO of Estuarian. I graduated from MSP last year, and as they mentioned, I was in the iGEM team back in 2022. A bit about the startup / the project itself. We use modified bacteria to filter salt from seawater to produce fresh water for people to drink and also use agriculture. And this invention that we've created is more energy efficient and cost efficient. Thereby, we're converting it to a startup and actually putting it out into the world for people to use. Based in Camelot currently, still live in Maastricht, and it's nice to see all of you. Looking forward to the discussion with all of you.
So hi, my name is Massimiliano Simons. I always say I'm not Italian, just so you know. I did my PhD in philosophy on synthetic biology in Leuven. I have a background in philosophy and sociology, so to give you an idea, what interested me was and maybe to distinguish me from the other philosopher, is first of all philosophy of science more than philosophy of technology per se. I was interested in what science means today and how science is changing, especially through technologies, and synthetic biology was the perfect case for this. And the other bit is as a sociologist, so what I also did was indeed go to laboratories and study these weird beings called synthetic biologists, and indeed also look at the history where it comes from.
Hello, so my name is Nina Holland, and because you've all been so kindly very short, I'll steal an extra minute because I think that our work is probably much less known to you than probably those who are, from Maastricht University or teaching you. I studied environmental sciences in Utrecht, environmental studies, so more the policy side, and I graduated back in the days, a long time ago, on the new directive on patenting of biology and living organisms, the EU Patents Directive. And my focus was because I chose the topic because I found it really fascinating, the question who genetic material, living material belongs to, who the seeds belongs to, and whether you can actually patent something that is alive and self-reproducing. And nothing is more actual, that's probably just a Dutch word, relevant at the moment in the biotech discussion today in Brussels as well. I haven't worked my whole life on GMOs at all. I mostly work in CEO, we are a lobby watchdog, we work on fossil fuel companies, banking, you name it. I focus mostly on pesticide companies who happen to be also the largest seed biotech multinationals. They are one and the same company. That's where a lot of the problems and a lot of the debates arise. I traveled a few times to Argentina and Paraguay to film and document the impacts of herbicide-tolerant monocultures on local populations, trying to stop the import of these bulk products into the EU to feed a very nefast system of factory farming. And within CEO, having addressed several topics and having worked on studying industry's lobbying tactics for quite a while, somebody came to us and said, well, listen, the European Commission is at the moment deciding the regulation of a whole new generation of genetic techniques. And when we looked into that, indeed that was the case. In 2018, this was followed by a European Court of Justice ruling saying that all the products from genome editing should be regarded as GMOs, should be regulated, biosafety for health and for the environment, should be labeled, and the rest of it. So from that moment on, a huge lobby battle broke out from the biotech industry, but also very much pushed by certain research institutes, such as the VIB in Flanders. And this has really now progressed to a moment where we are about to see a complete deregulation of the products of genome editing for agriculture. So mostly plants, but it's very likely that animals and microorganisms will follow next. I was also on the, as an example of how science and lobbying can conflate. I was on the advisory board of an EU-funded project here at Maastricht University called Recipes, about the innovation principle. And I felt it was basically my role, even though Dow Chemicals was also on that advisory committee. I would normally never have accepted. But the innovation principle was something invented by a small lobby group in Brussels composed of the largest polluters, so from heavy metals, chemicals, to tobacco, and basically trying to undermine the precautionary principle that is one of the legal principles of the EU legislation and EU treaties. So that fortunately became, had a very, I think a very positive outcome, very healthy debate on why precaution is needed. And yeah, I can say a lot more about what we are witnessing every day in the EU in terms of the undermining of environmental, social and health legislation by industry, and how science is being abused to that effect. And I would say it's never more relevant than today. I don't know, you've probably not watched the von der Leyen State of the Union live this morning, probably, maybe you have, but it was really a terrible show of contempt, I would say, talking about simplification of environmental legislation, where actually they are breaking down environmental legislation as we speak. It's not only a rolling back of the proposals of the Green Deal of the last term, but it's going even further, trying to reopen existing legislations that are supposed to protect us from harmful chemicals. Promises that have been made to ban PFAS are being rolled back as we speak. So, yeah, I'll leave it to that.
Thank you. Because we do want questions from the audience, you can ask them directly if you'd like to, but if you'd prefer not, you can scan the QR code and send them, and then we will ask them on your behalf. You can ask or send questions throughout the progression of the debate, so feel free to scan the code.
And we will do an open Q&A session after the panel discussion.
Okay, then we will start with the first prompt. In 1912, the term synthetic biology was first introduced as biologie synthétique by the French chemist Stéphane Leudec, who has been quoted to have said, "Why is it less acceptable to try to make a cell than it is to make a molecule?" Later, the term synthetic biology was used by Barbara Hobam in reference to genetically engineered bacteria. Since then, synthetic biology is the widely accepted term to describe the re-engineering of organisms with molecular tools. With these organisms often being described with technical language, there is a distance between scientists and the living organisms that we work with. How can language shape or influence the way scientists view synthetic biology, and what does synthetic biology and genetically modified organisms mean for you?
Whoever would like to start can jump in.
Okay, I'll start. I mean, there's a lot of things in that. Maybe I'll just launch a first provocation, but not too hard. I mean, the story of Stéphane Leduc, it's true, indeed he used the term. And linked to this question of language, you might think then, okay, then we now know where it comes from, synthetic biology, but I want to go against that image. I think you should step away from this ideal of we have to find what synthetic biology is by finding its history or something, as if it's out there. Because then you're avoiding your own responsibility, I would say. And that's the importance of language, right? It's a choice of when you want to start it. There are many options. And honestly, what the Duke is doing and what iGEM is doing right now, you could also say it has nothing to do with one another. I mean, he was really just trying to mimic chemically some things that look like life, right? Many synthetic biologists would not even call it synthetic biology anymore. But so there's a kind of a question, similar with the thing you mentioned earlier about, oh, we have been doing GMOs since, or we've been genetically modifying cows since agriculture came into being, etc. This is a choice to make that continuity, that makes certain similarities pop up and other dissimilarities, shifts, disappear. For instance, synthetic biology, you could also say it starts in 2000 or a bit around that when indeed Drew Andy, etc. claimed that label. Anew, indeed, it was there, but it failed, and now they claimed it and they did something else with it. And it's a very American story. It's not a French Duke story. It's a very MIT story. It's a very much infused with a kind of venture capitalist vibe as well. That was a completely different story. So in that sense, I would say step away from the idea of, oh, we can just find out what the real history is of synthetic biology. Is you have to make your choice. And that will probably tell a lot about what you are, more than about what history is.
I can respond to that maybe. There was a lot in what you said. So, and I'm not a philosopher, so let me see what. So, what I think maybe the term synthetic biology is not the right term. However, it says something about. There's always controversy of synthetic life and natural life. So it's to make the opposite of natural, let's say, and where is the line between something that is living and natural, or something that you can create completely from scratch. It can be using biological molecules. To me, it doesn't really matter if you use biological molecules or inorganic molecules and make something that can replicate itself. Where does life start and where does life end? And using the term synthetic biology to me means something that you can create, that it's not naturally living, let's say. But that doesn't say anything about why you would use that. It just says, to me, it says something about that it's not completely natural. But to me, that's not directly a bad thing. Does that make sense?
Yes, I think I like the question because it's about language, and for me, synthetic biology sticks because it's a weird mixing of concepts or fusion of categories. We have engineering and we have life, and for the longest time we used to separate the two, and we would use engineering for inanimate matter, and then we say, okay, we built a house, but now we didn't build nature. Even if we bred better cows every year, we didn't build them. In let's say the breeding of the cow, there's an element of dialogue with the organism, and the organism responds in a quirky way and develops, etc. Whereas if you build something, the idea at least is that the matter doesn't respond, that you are in complete control. So for me, synthetic biology incorporates this idea of absolute technical control. And it's questionable whether we should aim for that, but that's really a matter of how you consider what a human being is and what a good life for a human being is. And it's maybe a little bit, you mentioned the word whether it's natural or not. The word natural is very complex because I have these glasses and they're not natural at all. And I can go in the wood and eat something natural and die in 10 minutes. So natural isn't good and unnatural isn't bad. But if we dig one level deeper than this, let's say, rhetorical point we score in debating clubs, then you can also say that people who use the word natural, they aim to express something that deserves respect, or maybe reverence, or maybe awe. Something that somehow is larger than us. And in the idea that we can control nature, there's a kind of what the old ancient Greeks would have called hubris, overreaching, over control. Now, Eric, I'm going to face the objection for him, will say, where's the line between? There is no line. It's from all the important things in life, maybe your last breath, there is no hard distinction. So we will have to treat very carefully and keep discussing where we want to draw this line. Do we want to save some space for this reverence for nature? For me, it's almost a spiritual question. Now, last sentence. If this French guy, Stéphane Ludek, says, why is it less acceptable to try to make a cell than it is to make a molecule? I have an answer to that question, but I'm pretty sure that I would not have been able to convince him. Posing the question is a rhetorical one, and basically saying, okay, everything is up for grabs.
what is your answer?
What? That there is a line, that we should be aware that there is a line that you can't, that we shouldn't overextend control, but I will not be drawn in the debate where that line is to be drawn instead.
Thank you.
Maybe just to add to that, I mean,
It was what you did.
yeah, I know. I wanna pick on. I think what is also very crucial in this question of language and natural versus unnatural, and the difference is, so what synthetic means can also mean many different things, right? And there's a kind of a game that can be played within the debate on shifting the meaning, so to avoid, like, what is synthetic about synthetic biology? Some would say it's the product, right? We create something that didn't exist, or it's the resource, we use non-natural things to create something lifelike, or it's the process, right? We do it in a synthetic way rather than in a natural way, but with natural things. Or you also have this idea of synthesis as bringing things together, making, like, not analysis, but synthesis, bring it all together. And this has repercussions, of course, of what are we actually doing, again, what is it continuous with, also with the kind of legal questions of what can you patent, are we patenting the product, the process, that has all kind of repercussions there. So sometimes the debate focuses too much on also on what is natural, whereas synthetic as a term is actually also very fascinating and very complex in that sense.
I do agree with the point that there is no strict line, or it's not black and white, or it's mostly gray, and that there's a spectrum between what is natural versus synthetic. And the terminology does help distinguish the far ends of the spectrum, but we would rather have to think about the between. Where do we say? Where do we to answer the like his question about modifying the organisms just because we have molecules? Can we do it with life? To answer the question, we would have to think about where in the spectrum do we consider it too far on the synthetic side versus the natural side.
I want to say something about the sort of rhetorical trick, going back to human agriculture and breeding, because I once uncovered a PR guide from ASTA and ESA, now it's called CropLife, so the seed industry lobby, and it was all about that. So it was all about how this is nothing new, how to avoid technical language, how to create confidence among consumers, because consumers largely reject GMOs, so don't talk about it. And precisely showing the continuity is fundamental in talking to the consumer and the public. However, when you talk to investors, it has to be disruptive, it has to be unprecedented, it has to be new, because otherwise you can't patent it. So there is a huge gap, a huge divergence I wouldn't say schizophrenia, but it's a really divergent communication line that are being used depending on the audience. It has been tried in the debate on genome editing. Technically, I think there's no question they are GMOs. However, it's been presented first as new breeding techniques, precision breeding. A lot of things have come from the industry. The Commission finally decided to create a new term, new genomic techniques. Nobody knew anymore what this was or what we were talking about. Most people have heard of CRISPR-Cas, so we usually say techniques like CRISPR-Cas. I think another interesting aspect of all of this is the promotional language that we hear, that I just mentioned. There's even academics who analyze this, who analyze how promotional language is being used in research articles, and this is really important because most people only read the summary. AI screens the language and contributes to the notion that people get of the knowledge that is out there, which is probably exaggerated. And finally, so what you see is that there is an exaggeration of the benefits and an underplaying and ignoring of the risks. And a lot of work on this has been done by one group in particular, etc. group, ETC group in Canada, based in Canada, but they are an international group. And they basically call this extreme genetic engineering because you don't only interfere in the genome, you don't only delete something or add something from another species or what have you, you write the code. And this can lead to vast changes in the organisms and therefore in the biosphere. Because you're not going to do this once, you're going to do this thousands of times. And therefore you have the potential to vastly influence ecosystems that are already hugely under stress from pollution, chemicals, etc. So I think that is one thing that will be one of the red threads in my thinking on this tonight is that there is too much focus on the potential applications and not enough on what are we actually doing and who did you ask? Is this really the right solution? Why would one technology be the right solution for this whole host of health problems and climate problems? Those are really big questions and ask for a bit of modesty, I think, on the part of the developers of the technique.
I would like to bring the conversation back to language. Anirudh, as a CEO, do you consider the way you talk about the things you were developing in a corporate or different setting, like the way Nina was describing?
Partially, yes, I do agree. Because at the end of the day, the audience, if we are talking to the investors for us to develop a new technology, we have to convince that they are disruptive or something like innovative. We're doing something that doesn't exist completely in the nature. So the term probably used to technical people versus non-technical would be vast. And I would like to add to the language prompt from before to this is that in terms of synthetic biology, we consider genetic engineering, and we bring a lot of terms from the engineering world into the biology world, like genetic circuits or like a chassis organism or something like that. And I think this does help communication between scientists in the synthetic biology realm, but it makes the actual synthetic biology quite contained into a small range without including stuff about how it would work in the environment or stuff including past the lab scale, let's say. And yeah, I think to answer your question, coming back to your question about communication, it does differ, and terms really have a lot of meaning to them, even though it's not only about where the word originated from, but for example, the use of the word GMOs is usually quite frowned upon, and even though I would want, like we are creating modified organisms, we now describe it using bioengineered organisms instead of genetically modified organisms, because then that just sheds bad light due to previous mishaps with it.
I would like to add, if I can, I think using different languages to different people is not a bad thing in itself, because I communicate with different people, like the general public, say it like that, people with no scientific background. If I want to explain what I'm doing, I need to use different languages, otherwise my message is lost. And if you communicate, to me, the most important thing is to get my message across. I do have to say that if I have to write a grant, I hate the word groundbreaking or those kinds of things. I hate it, but sometimes you have to use it. I'm not saying that's a good thing, but different audiences using different language. That's
Different languages is something else than simply contradicting yourself. Yeah? If you say to one audience, business as usual,
no.
to the
I
other,
get
it's
that. I get that.
disruption, then it means
That's right. I get that.
And maybe also, sorry, in addition to that, I think usually when communicating with investors, at least for us and what I've seen with other early stage companies, the disruption we talk about is the impact, but not the impact of what we've created. We can go into the patents in the future, but I think what to communicate, the much than contradicting ourselves, as in we're not saying that we've disrupted by building CRISPR-Cas9. We've used CRISPR-Cas9 and similar technologies to build something which could cause a change.
As a final word, maybe, I do think that tonight we're discussing these technologies, the pros, the cons, and that's fair enough. But very often, a lot of the attention and the energy and the resources tends to go to these kind of topics, and that is because they need to be promoted, because a lot of people are drawn to it. A lot of people panic about climate change, rightfully, but somehow also forget about the other planetary crisis that we're facing, and one of them is biodiversity. And there you get into a really awkward situation, because the solution that you're promoting is at the same time can be a huge threat to further destabilizing ecosystems at large. So you need to be honest and upfront about the risks. There are applications that stay in the lab, okay. Clearly we want them to be regulated, the labs need to be safe, you can't always assume that. Therefore regulation is super important. And then there is the applications that happen outdoor in agricultural systems or even in nature. And that is very fundamentally different. And you need to be very upfront and honest about it, about potential benefits, but especially also potential costs and also the opportunity cost. Because instead of using public funding into one direction to address climate change, you can also use those funds to in another direction to change the way we live, to change the way we do transport, you know. So I think that's another part of the debate. So why do we talk so much? That is part of the hype, you know.
One last thing before we continue to the next question. Nina, should our language discriminate these different applications that you're describing?
I'm not sure. I haven't thought about that. I think it's important that the language reflects what you're doing and what the impacts could be and why you're doing it and who's benefiting. That's a bit difficult to put that all into one term. But that's why I do understand groups like etc. Group to call it extreme genetic engineering, because this is not business as usual. It's not.
Thank you.
So now we're going to go to the second prompt. For most of history, biology and science in general have been viewed as controversial. Their political secularization is a recent development. Synthetic biology involves the interference of natural processes, which puts it into a unique position in comparison to other biological sciences. It is and will forever be something political. How can legal regulation and politics affect GMOs usage, and can the regulation be considered to be against scientific development? Or do environmental and health regulations promote responsible innovation?
Maybe a small start, warm up again from my side. I mean, there is a kind of, this is me speaking as a sociologist, the kind of a bias here, as in there's this idea that you have science and then you have regulation that stops everything else. As if you do not need state or regulation to even make development, the actual development happening, right? So regulation is not there just to stop things. Regulation is also there to enable things, right? If you do not have clear rules, there will be no companies, right? If you don't start a startup, if you don't know what you're getting into, or that you're protected in certain for your property rights and whatnot. So that's the point I just wanted to make. In that sense, you need regulation to get GMOs. The question is, of course, what kind of regulation? Not so much just anti-regulation or pure pro-regulation.
Okay, I think there's something of order here. Yes, I of course completely technology do we need for a better world? That should be the overarching question. And then we shouldn't succumb to technological solutionism in the sense that we have a solution looking for problems. That's often happening. It's also what Nina described. We have synthetic biology. Where can we put it to good use? That's the solution looking for a problem. But because every solution takes up scarce resources, so we should always have a discussion on what are the alternatives. And that's the least asked question in these debates. Can we put the money to a better use? I'll give you an example. It's not directly related to synthetic biology. I've also been a member of the Health Council, and we did a study. What disciplines in the hospital contribute the most to health? Which one has the optimal health gains? It's not the surgeons, and it's not the people who write studies in molecular biology. It's the people who work on prevention and on care. Now, if you look at the internal hierarchy of a hospital, you will see that all the well-paid positions are in surgery and molecular biology, whereas prevention and care is usually dismissed to the lower temporary staff. And there's a gender aspect to it. You will see the males in the high-paying corner where all the hypes are and all the publications are, and you will see the women in the dark corner doing good work. So that report really shook me up, because we should ask these, let's say, very sober questions. What does this world need? And then the question is, maybe not synthetic biology, but maybe something else. Maybe it does. So I'm completely open to a good business proposal. But we should always ask the question. And this also basically means that we should have a democratic debate about what we want. Where do we want to go with technology? And now it's basically in the hands of ever fewer large businesses buying up startups. That's where we delegate the power over our lives to. Let's say something right.
I totally agree on that last point, by the way. But I forgot my first thing that I wanted to answer. But you mentioned something, and Nina mentioned something about where do we put the money? Do we need synthetic biology, or should we just change our behavior? As an example of one of my projects was around reducing the methane production in cows. Methane is a greenhouse gas, as you all know. The most heard reaction of people was, why do we need that? People should stop eating meat. But that is not the solution. So it's not. I'm not saying that we should all put all our money in synthetic biology. It's more than one solution that we should focus on. Is it synthetic biology? I don't know, but maybe it can help. I was triggered by what you were saying about it. Should we change our behavior? Yes, sure, we should. But it is not going to be a solution that will happen in the next 100 years. People will still eat meat in the future, and maybe we do even need to breed cows or cattle.
Yeah, I had to. I was a bit amused by that example, because that was the example I read when I looked on the iGEM page, which was about the seaweed, right? So you found something in the seaweed, and then now it was said that it's difficult to produce seaweed, therefore we produce it with bacteria, and then the cow emits less methane. But then, yeah, looking at the debate about indeed about the protein transition, so to eat more plant, not no meat, but like more protein that comes from plants, which makes sense in so many ways. Is it really that difficult to produce seaweed? We can easily produce a lot less cows, and feed them some of that seaweed and we're perfectly fine and we'll have some extra jobs of people living in coastal areas. It's already happening. There's lots of new facilities producing seaweed, etc. So I was like, so to what extent were people involved in agriculture, for instance, I lived on an organic dairy farm in Brittany at some stage. Like, their system of producing is so sustainable, and then you would make them again depend on another product that is owned by who knows what, whereas they are already, farmers are already in a very dire situation, having to buy a lot of expensive inputs. But what they're doing in their organic system, they have completely eliminated all the inputs. So they're not using antibiotics because the cows don't produce less milk. They are not importing any, so they have completely grass-fed, so they don't use any imported animal feed. So these examples are also there, and they are less, slightly less productive on a per hectare or per cow, but they are a huge example of how things can also be done. So yeah, it's in those things, like to develop those bacteria is really resource intensive, and I'm wondering if you compare that with other agronomic and consumer action, would that not be a lot more effective? I'll let you respond, but I also want to say something about whether legal regulation is against scientific development. That is, to me, really provocative. Because in what world are we right now? I mean, it's not, as I said, it's not just climate change, it's also very much the pollution, and the pollution that is happening every day, the molecules that are being invented every day, that are not properly regulated, and that are being brought into our environment day after day after day. It's getting very close to us. You just need to look at Zwijndrecht near Antwerp. People have personally suffered the effects and can no longer eat the vegetables from their garden. It's all around the Netherlands as well. So why would you, in that situation, where should the priorities be? And how could you argue against regulation also on synthetic biology and GMOs? Because they do have the potential to contribute to environmental and health impacts. Last thing, today and last Sunday, maybe the Dutch-speaking among you have seen the Argos emission. And today there was an article in the Groene Amsterdammer based on our research, because this is what I do. I ask the Dutch ministries and the EU constantly for documents, their emails to lobbyists. So we get these piles of emails and exchanges between officials and with lobbyists and so on. And this really shows how the Dutch government actively is serving the interests of a few big corporations, opposed to a whole set of small breeding companies that are really important in the Netherlands, that have developed a more cold-resistant and a longer-growing maize that are now being threatened by patents from some biotech companies. They are really threatened by the deregulation of genome editing that will basically open the doors for patented products to flood the market in the EU. So I would definitely recommend you to read the story of this company called Nordic Maize Breeding, and maybe circulate it and do an automatic translation or a better one, because that's really interesting how it really affects small, medium-sized companies.
Maybe one sentence on legislation then. It's often presented as if there's a law, legislation against creativity. That's obviously not the case. There are laws that say, okay, you can't take this route, so put your energy there. A very famous example is the development of pluripotent stem cells. Because the easy way was to harvest them from embryos. And then there was a law against using embryos. And then people said, yeah, but we need those stem cells. So they became more creative. So it's simply a system of incentives and hindrances that guides where we want our creative, brilliant minds to think about.
Yes, definitely, because I agree with the point that creativity is not really bounded. I think the thing that regulations are trying to do is to create a boundary that we as a society and humans decide to not cross because it could have harmful effects for the betterment of the humanity or sorts. And creativity does come from these boundaries because you have to figure out a solution which works in this space instead of endless creation. But I would like to also, maybe not looking at the specific example of Methadone, but the identity that we were talking about before, but to talk about the technology itself, as in why do we have to fund synthetic biology or this over behavioral changes? I'd like to pose that as humans we've done some mistakes in the past. We are doing some mistakes in the present with the bigger companies also dumping the PFAS and everything. And we do need to find solutions, not to go look for problems, but look for solutions to problems we've created in nature and etc. And to find solutions to these problems, why would we not go also to look into possible techniques to solve this problem? Why would we choose one over the other? It's the same argument as in to ask why would we fund synthetic biology? Same question applies, why would we find another technique? Because that also could, like, synthetic biology could be better than that. I think we should start with the problem itself, looking at potential solutions for the problem, and then deciding on whether synthetic biology could be a solution, a better solution than the other one. That's definitely a possibility, but I don't think we should disregard the fact that synthetic biology is this thing that humans have found out to be a possible way to solve the problems too.
I would just like to ask Eric and OmniUm, as our natural scientists, is your work affected by regulation, by legal or political regulation?
In some way it is. I mean, I run a very small lab, but I know that I have to follow very strict rules in using GMOs in our lab. And I'm not against regulation at all, but at some point I see how ridiculous some of those regulations are. And it slows me down in the process of taking the next step because I have to fill in 1,000 forms and I have to do this and that. It's not only annoying, I also think it literally slows down my process of doing research. So yes, in some very small way it does.
Yes, regulation does affect it, but and I think it's good that it affects it, but I think there's an extent to which it should affect it. So I would put it this way, as in adding to this point, regulations are definitely good. I'm not against regulations, and I think it's good because we don't want to do something which we did not intend to do, causing consequences which we really do not want. But there's a point where regulations also become quite hard to implement these technologies. Suppose we did find out that synthetic biology is a better alternative, then the regulations might take us longer to implement the technology, bringing the benefits taking much longer to be present. And I would like to also add that in terms of regulations, at least for the GMOs, there's two types of regulations, which you probably know from the GoGEM. There is the contained use regulations and the environmental release regulations. And I do believe that definitely for the environmental release, it should be more stringent, and we have to be careful about what we're putting out into the environment. But with contained use, I think as long as we make sure that we're not releasing anything into the nature and use this synthetic biology as a technology to for example, I'm going to use my company, but just as an example, to bioremediation or purification of water, as long as it does not end up in the end and we're not causing ecological systems to differ,
for adding another layer of legislation, and it's called technology assessment. It's not legislation as such, but I think it would be really useful to have a process by which you give information on all aspects of a certain technology or a certain problem, maybe rather, and ask a wide diversity of people to come into dialogue about that, and to learn how society feels about it, what all the different pros and cons could be. There are discussions about this at the UN level, in the Cartagena Protocol. There are advocates like the Ratenau Institute for Technology Assessment here in the Netherlands. They've researched people's attitudes towards GMOs, who is not that negative, but they do want to have the freedom of choice. However, the government just ignores all of that research. It was also in the Argos program. So where technology assessment is being done and advice is being given from society, it's just conveniently being ignored. But I would really sort of advocate for that, and especially because you're now talking about organisms that have more profound and complex changes that could also be more, would make new demands on the biosafety risk assessment. And for that you need independent expertise, and that is very often lacking, because most people work in the development side and not in the biosafety regulation side. So that is a really big problem. Of course you have all these applications that are in the lab, but there, what are the implications for livelihoods? Maybe not your application, but all these substitutions of natural substances like vanilla or food additives or all sorts of products that are right now produced by people out there around the world, having their livelihood depend on a natural substance, on something that grows in their area, an agricultural substance, could be produced by bacteria, and those bacteria have to be fed. It's not like a clean system, it's not like it's coming out of nowhere, so you have to feed them sugar. That has to be produced somewhere as well. So where's all that sugar going to come from? From the sugarcane monocultures in Brazil, or the fields here where they use large amounts of insecticides, etc. So it's not. We need to look at the whole package. What is it doing to the economy? What is it doing to different groups in society? And for that you have technology assessment.
Thank you. Yes, go for it.
One sentence. That's it. I completely see where you're coming from, but I think this is asking too much of single startups. Yeah? So if we want technology assessment to be done, we have to organize it somewhere. Right?
Maybe one sentence that triggered me as well. You said that you should look at the whole picture, but very often I hear examples of that whole picture by pointing to one specific small area, like the farm that you were mentioning. I'm not always sure that if you can extrapolate a smaller situation that works for the whole world in the situation that we are in now. Well, in this case, it was about methane reduction in cows, greenhouse gas reduction, or feeding with grass, but you need grasslands, right, for all the cows. Do we have enough grasslands for all the cows in the world to feed the people? And you say, okay, we can reduce the number of cows. Also true. I totally agree that that would be a good solution. I'm not sure if that will work. So we need to focus on not only that solution, like you were saying, not only on the synthetic biology solution, but maybe on more than one.
Okay, thank you.
Sorry.
Sorry, no. Perfect. So due to time, we're going to skip one of the prompts.
Which you kind of already answered.
Exactly, because we're going to have some more discussions. Recently, George Church, who is said to be the godfather of synthetic biology, attempted to revive the woolly mammoth by combining frozen mammoth DNA with elephant DNA. His reasoning is to revive an extinct species with the ultimate goal of helping reverse climate change. What are the general ethical considerations of releasing GMOs into natural habitats? And do we have a responsibility to conserve or to reverse our climate, if possible, with GMOs? We don't have to follow the same order if someone else would like to start.
Not you.
There may be a technical start.
So let me summarize. What was it? Summarize. Do we have the responsibility to conserve or reverse our climate? Reverse the climate. I just put this out there. Sometimes I think we have the responsibility to actually do so. I think when we have a solution for something, we have some kind of an obligation to use it. For example, if we can save blind children in the Philippines with the rice, I think we have the moral obligation to do that if that solves the problem.
Can you
can also-
expand on this example?
When was it? A few years ago in the Philippines, they had the golden rice. It was allowed to produce it, but there were a lot of, I don't know the name, Greenpeace was involved, I think. And in the end, 2 years ago, they banned it basically. But my point is that not being allowed to produce this golden rice that saves children from becoming blind, it produces beta carotene, which is converted to vitamin A, which makes you blind if you have not enough. It can save children, and it was, in my opinion, proven to be safe to use. So I think we have the obligation to use it if it is safe. But yeah, we have to define what is safe.
Golden rice. Oh my god.
I knew it, that's why I said I put it out there.
Yeah. As soon as you criticize golden rice, the next day you're going to be in the newspapers as a child killer or something like that. The WHO has an extensive vitamin A program for decades, which is very effective. It's vitamin A deficiency in children and in people in general is about poverty, is about not having access to a healthy diet, right? Usually when you feed somebody vitamin A, it's not going to work. You need it in combination with oil. So already it's more complex than just putting something in the rice just because people eat rice. It would be like, okay, we're going to put all the vitamins you need, we're going to put it in your staple product, and then you're fine. You know, you don't need your little gardens. You can just work and just depend on the rice. Whereas, of course, the problem is that people have lost access to land, access to healthy vegetables that actually deliver the vitamin A. So what Syngenta has done by putting the vitamin A in the rice seemed like a very simple solution, but of course, if that has to work and it has to get to all the children in the Philippines and elsewhere, they all need to eat the same varieties of rice provided by Syngenta. That is the problem, because there are thousands of local varieties of rice in the Philippines and elsewhere that have all these different characteristics that we shouldn't lose, and we don't lose them because farmers are growing them. And we lose them if we adopt a few varieties of rice that contain this vitamin A, which is immoral not to use because otherwise kids don't get the vitamin A. So you see a bit the conundrum, like it's a very simple story, and like, okay, how can you be against this? But if you see the large scale applications of actually, like, so we're treating malnutrition with one rice, that is a huge threat to the resilience of agriculture. So what people are now doing is they are putting samples of seeds into a vault somewhere in Lapland in order to save genetic diversity, so that later when we need it, some of these varieties are still there to use. And yeah, what is the real solution is in situ conservation of these varieties, which means lots of farmers growing lots of different things. So that
should go hand in hand, no?
well, it's a bit difficult to see how it goes hand in hand. The system of agriculture where local people have access to both rice and other vegetables and what have you that you need to get your vitamin A, and a large-scale system whereby you are all dependent on this one rice.
I'm sorry to
Yeah,
interrupt.
so that was golden rice, but we were talking about the woolly mammoths, right? That was the actual
I'm so sorry to interrupt, but
question.
would someone else have something that they would like to say? Your perspectives.
Maybe I can pick on that. I mean, indeed, I wanted to link exactly this discussion to the woolly mammoth example. I think, in a certain sense, it's the same kind of point you would make it. I mean, let me be very nuanced. I think it's complete nonsense. This idea of this, the extinction. I think even many of the scientists agree it's a kind of a nice PR story, and I think it points to something. I mean, maybe to make a larger point out of it. In these discussions, and there have been studies towards it, like it's not an opposition between science and non-science or something. Even in biology, you can see people who have a background in more engineering, molecular biology, versus more, it's no accident that you have a background in environmental science, etc., more ecological, more holistic perspective. And those two scientific perspectives that typically result in different views on what to do with it. Either you focus on, because you're trained in a laboratory to be very, I mean, within certain settings this works, and now let's try to expand on that, versus if you come from a more ecological perspective, like the mammoth, you immediately think about, yeah, but what kind of environment is it? Did it originally live in? It's not around anymore. Do we have to recreate the environment? Are we not just creating a big zoo then? Is that the game that we wanted to do? Are we indeed basically destroying existing ecological systems to get the mammoths in place, etc.? Same with the dire wolf recently. Well, it was a very similar story. It wasn't even a real dire wolf, etc. But so we shouldn't just not talk about de-extinction in that sense, especially not as George Church, who is a nice storyteller indeed, as a solution to climate change. I mean, that's never going to happen.
I completely concur. It used to be the dodo. Before climate change became hot, it was the dodo. And it's called synthetic Eden. And the only purpose of these examples is to shut the ethicists down. Because they know that all the ethicists are saying, whoa, but we need to worry about climate change. Yeah, but I have the woolly mammoth for you, right? I can restore biodiversity. You were so afraid of biodiversity, let me make a difference. So basically, it's you take the values of the opponent, and then you come up with a technical fantasy that will shut them down. In the game industry, we call this a killer application. You want to sell your machines, but you need one game that everyone wants to play, so you have to buy a machine. So the golden rice will save the children, that's the killer application. The woolly mammoth, that's the killer application. And then as soon as you say, well, let's do the woolly mammoth, now shut up for all the other applications.
Unless anybody has anything else to add to this prompt, I think we can move on. Anya, do you have this moment?
Yeah, it's a mixed opinion, but I think I agree mostly to the fact that using like de-extincting organisms, I don't know if that would be the way to climate change. Going back to the question of what are the possibilities, and I'd like to point out here that in synthetic biology itself, there are different solutions where de-extinction is a possibility. There's another technology. It's just that we have to decide on like boundary where we're like, okay, but de-extinction goes too far into changing the natural environment for a problem that we created. But there is a better solution. Why would we have to go for that? This?
Short and sweet, I like it. We will move on to our next two prompts, which I think we can combine into one. We're going to be moving on to people.
So just a bit of context on a story that you might have heard of. He Jiankhu was recently involved in a scandal and even sent to prison for conducting one of the first cases of human editing by editing out the HIV gene from 2 human embryo twins. This was revealed to the public by a MIT technology review, with him receiving widespread criticism afterwards. At best, He Jiankhu is considered to be responsible for stopping a deadly disease from developing in babies, and at worst, He Jiankhu could be considered a eugenicist. His quotes range from "gene editing should never be used for cosmetic, military, or performance-enhancing use cases," and "designer babies, super smart or super good-looking, are inevitable." Should society allow limited gene editing to prevent illnesses from being passed down? And looking more into the future, how do you think human gene editing will progress, and will its importance increase?
Okay. Let me take a stance, and I would basically say, should we allow it? No. Why not? Because I mean, you could basically make the argument, if we could indeed cure certain diseases and then also the children, I mean, the simplest, probably ecological, more sensible solution would just be you cure the disease if they have it. You don't need to pass it on. I mean, there's a story there of simplicity and etc. in there, but that's the crucial question for me. Is that worth the risk? It's not a question about saving their lives versus not doing it. It's a question, do we need to pass it on? That's indeed the extra element here that I would say it's, in the current state, I don't think we need it. We shouldn't do it. I mean, we already have, the big question is curing people who actually have it now, and not immediately trying to see what will happen with the next generations.
I agree on that. I'm not an expert on human genetics, but I totally follow the rule of not passing it on to the family line, but treating a disease if we can and do it. If the other option is death, then I think that's a no-brainer.
Quick terminology word. There's the somatic mutations and the germline mutations. That's what they're trying to differentiate. When somatic, it's like the individual who gets the treatment is the only person who gets the genetic modifications for a specific disease, let's say. And the germline mutations are for mutations for people or babies that will be born based on that person and also continuing on from generations. I think, personally, from what I understood from literature and what we have, we're not to the point, like we've not reached a point where we've found the technology which would reliably do both somatic and germline is much farther, but we've not even found the technology which would reliably do somatic mutations for most of the diseases. The first few ones are coming out, and I think the biggest reason that he got arrested for modifying the babies with HIV through CRISPR-Cas9 was the off-target effects that it could have caused, and it's not because he did something that, like the question is not, would you support treatment because someone is dying, and is it just no? It's just because that we have not found what where we, like, I don't know, we found fire, let's say, back in the day, but then we don't know where it ends. So we have to first figure out what the circle or where we are, and then we have to make progress into somatic or disease-related job.
Nina.
Yeah, what I understood is that he tried to insert resistance to HIV in these babies, and he recruited several couples of which the father has HIV and the mother does not. That's my understanding. So there's no HIV gene to be taken out or anything, as far as I know. So that was his experiment. So there were no babies to be saved or anything, okay? And already 15 years ago or longer, it's possible to have an HIV positive donor and clean the sperm and have a healthy baby with HIV. That's with IVF. Sorry. Sorry. All those acronyms with IVF. So that is miraculous, I find, but that is possible. So there's no need to transmit the disease to your children when you have HIV. So I find it I find it a mystery, this experiment. Why this example? I find it flabbergasting. And it's indeed a slippery slope to, if this can be done, then to what other causes should we be genetically modifying human beings? They've never asked for it because they haven't been born yet, and their offspring hasn't been born yet either. And you can't experiment with people. Nobody accepts. There's a lot of protest against testing on animals, but nobody even considers testing chemicals or what have you on human beings. Only maybe in the medicinal field.
Can you connect human gene editing to your experience in corporate lobby to any extent? In terms of risks? Maybe I'm not making myself understood. Do you,
Try again.
yeah. Based on your experience, if this were to be a technology that would be introduced, how do you think companies and corporate lobby would play into it? Would that be a risk factor?
Right. I mean, there's a huge amount of stories about how the pharmaceutical industry or how they would, you know, how much, how far they're prepared to go to earn big profits, like, you know, like patenting medicines that otherwise would be available to larger populations in the world. But human gene editing is really something different, that is really not something that is being lobbied on, as far as I know. What I do know, but I know I've been a bit long, there was a film called Food for Profit, and the journalists made, they posed as a lobbyist to several MEPs, members of European Parliament. They basically proposed to create pigs with 6 legs through gene editing, because then you would have more ham. You know, it's just as simple as that. And they made it so convincing that several MEPs responded to that seriously, like, oh yeah, why not? You know, like, yeah, you could look if we can find some research funding for that, or, you know, like completely bypassing any sort of animal welfare considerations. But in humans, no, haven't seen.
Any final remarks on this topic?
My first one.
Yes, go for it.
I'll keep them very short. I just want to point out the rhetorics of this guy. First of all, there's this healthy dose of technological determinism, because designer babies are inevitable, so bits and jabbering, it's going to happen, whatever the ethicists say. And it's super sexist, because we can choose between becoming super smart or super good looking. Now, I wonder why you pick those two predicates, why we can't combine the two, and whether you're thinking about males who are super smart and super good looking for the It brings me back to the cloning report that I started my biotech career with. I reconstructed the whole ethical debate on reproductive cloning of human beings, and there were 8 or 9 arguments, pro and con, and in the end, the whole debate boiled down to one thing: you can't experiment with babies, with human babies. That's yet the untakeable hurdle. You can't produce 2,000 bad clones and then say, now we know how to do it. Yeah? And that's basically what this Chinese guy waved away. He started experimenting with cloning, with human babies.
Okay, now we're going on to the final prompt because we're a bit short on time. Mooney's law says a powerful technology introduced into an unjust society will always increase the gap between the powerless and the powerful. Creating genetically modified organisms is becoming more accessible and encouraged. Anyone can create DNA and order it, and competitions like iGEM encourage students to participate in synthetic biology. Yet money is the central decision maker on who can afford research and who cannot. Is it fair to leave synthetic biology in the hands of only people who can afford it? Can the scientific community ensure accessibility? And how can we mitigate the gap between the powerless and powerful in a society with GMOs? I would like to ask Nina. The quote is actually suggested by her, and I would like to know your thoughts in the context of this prompt.
Yes, so Pat Mooney is one of the founders of Etc. Group. The group I can't recommend enough. They are strongly engaged in the discussions on synthetic biology at the UN level. Pat's quote is really about how is really, I think, triggering scientists, developers to think about the implications of the technology and how, if we are not addressing power relations, how can we then expect technology development to contribute to a better world, which is also a more democratic world, if the undemocratic sides of society are already embedded in the research questions, in the research funding, in the patents, and in the research, especially in the research questions asked, so the direction that research takes, then it can easily lead to a more unjust society. I think we're seeing it with big tech, we're seeing it in different fields, where very often there is a lot of attention and hype around high tech, and very little attention and appreciation of knowledge and experience of people. There's now more recognition of the contribution of especially indigenous peoples to the conservation of biodiversity around the world. However, when we talk about technology, their knowledge is usually not taken into account. So I think that is really a bit what is behind this quote. And it was not my idea to then connect it to the second one, which is about accessibility of the technique, which is of course also an issue. But yeah, fair enough. Like that is something for the scientific community to be concerned about. But if we see that when you have access, then very often the startups later are bought up by the big companies. Then in the end, the public funding and your company in the end serves some very different interests. How are you going to prevent that? That's not a question I can answer.
What about our other panelists? Can you answer this question?
Not sure I have an answer, but maybe 2 points. One is, and I agree with what you said, but what triggered me in this question is always the debate is then indeed often opposed of like, oh, you have either the big companies or you have this kind of do-it-yourself biologist or the biohacker, and then the two extremes are there. I mean, at least we should also not forget the other actor in the room, which is the state, which, I mean, historically states in general, we tend to focus only on the Netherlands or wherever you live in. They don't have a nice track record of use of science, right? So there's also this question of if you are making available certain technologies, how are states going to use it, right? States can shift very swiftly from something very benign to something very problematic, and the technology will still be there. The other thing, maybe to link it, these two sides of the question was also, I mean, you have this label of, it seems to be a call for a democratization of science, but in different levels. And again, that can mean different things. The obvious one seems to be accessibility, or we should all have access to the tools, or we should all benefit from the outcome. But what is also in there is the other dimension of, it's not so much of we should all be able to play the game or should benefit from the game, but who defines the rule of the game? And I think that's indeed this question of, in this case, who defines the problems that we are trying to solve by science, by GMOs, and then indeed the question of the indigenous knowledge, the local knowledge, the public that is that you are, as a scientist, typically have an idea of these people need this. And then too often still, you don't even consult them, or you consult them very narrowly. You say like, this is great, you're gonna use it? Yes, okay. Instead of demanding, do you actually need it? How do you define a problem? So there's a kind of democratization of science that I would favor more than just accessibility. This question of how to make sure that we involve all the stakeholders from the problem definition, not just from the solution.
Yes, I completely agree with Mooney's law, but I don't know what to do with it. And I feel that we're kind of trapped in an unproductive play. We have people who make technology, that's usually market driven. Then we have people who critically watch, like Nina, say, hey, what's so much harm done. Then we have the neutral scientist who says, well, I do my work and I hope it's for the best. I have good intentions, but I can't control what other people do with it. We have the audience as fairly passive consumers of whatever good and bad comes out of it. And let's say the technology makers and technology watchers, they are fighting for state control. We want the state to be on our side. So that's kind of the game that we're in. And it's clearly that we may win this discussion, but we are losing it in a grand scale in the outside world. We're definitely on the losing end. Democracy is at the losing end generally, and for years I've said we have democracy and now we have to expand it to include technology and science, but now I would be fairly happy if we could keep democracy as we had it over the past decades. So the question is, and it's really a question maybe also for the discussion afterwards, how can we disrupt this rather improductive game? And maybe it can be helpful if the, let's say, the critical people like can somehow be more on the side of science or technology and can be let's not do this, but appropriate what's good and interesting and creative, and then maybe gain the trust of the scientist and then work together on different type of approaches and like. So I'm deliberately so because I don't have an answer, but I am looking so much forward to any ideas you have, how to get out of this rather unproductive cycle.
Do our neutral scientists have anything?
Yes, I agree that it feels like we're in a stalemate. We have all of these different actors in this game, or characters who have decided their roles, but then every new thing has to be debated by all of them and then move forward, which makes it unproductive as so. And I would also say that at the end of the day, most people want what's the best outcome to make sure that. I think at the end of the day, we have to define what good life means for humanity, and that definition would then be able to like explain our decision making. Because currently the decisions made, or like the arguments put forward by different players are motivated by different values or different end goals. And I think at the end we have to all figure out what good life means for a human being, and what does it mean for human beings to progress. Maybe it's better life expectancy, maybe it's less diseases, maybe it's restoring the environment. But I think as a democracy we have to come together to figure out what our common goal of humanity is, so that we can decide if a certain technology is actually viable and useful for us. Because it all depends on the scale, if it's from 0 to 10 or if it's from 0 to 100. So we have to define what the scale is, which the regulations tell, but I think it should be more, not only, I agree, we have to do the other way, but we have to do it this way too. I agree that the scientists also have to become more aware of their technology, not only what they have, but what the implications could be for the world, so that we reach a middle ground, so all of us can figure out, so it's not just a fight between the two, rather a productive discussion on a central goal.
So you're also pleading for interdisciplinarity, I think,
Yeah,
right?
yeah.
And it's I think that's really crucial, because you said, well, I'm trying to tackle the methane problem because people, by synthetic biology, because people are not going to change. I come from the social sciences, I say people change all the time, but biology is not going to change. And you say,
Not in
yeah,
that
but
science
it's-
field.
well, if you look at, I'm looking at the count, how many women are here in this class? 50 years ago in the Netherlands, you were not allowed to work when you were a married woman. So that's 50 years' time. If we look for the acceptance of homosexuality, it's 30 years. So things are speeding up, actually. Patterns that we have accepted as natural for millennia that seem to be up for grabs, because we are, if you believe in evolution theory, cultural evolution is speeding up, and we are trying to manage cultural evolution. So you are trying to manage biological evolution, but actually we are trying to become self-reflexive on the mechanisms of cultural evolution and see whether we can utilize those mechanisms for a better future.
Yeah, if I may, what is a good life? That's a very good question. Is it brief, a good life? Or I should be brief. It depends for who, huh? Because I organized a debate at Ghent University a number of years ago because the VIB, the Flemish Biotech Institute, was doing experiments with poplar trees to make them weaker, to reduce the lignin, therefore you need less energy to turn it into ethanol, and then you can produce biofuels or what have you. Good for climate, you would say, etc. And I was working at the time with groups in, notably in South America, fighting big monoculture plantations, eucalypt, pine, and poplars. And when we researched a little bit about, where are these poplars going to be grown, and by who and for what? And it's clearly not going to be grown in Belgium. There's not the space, the land is too expensive. Same in the Netherlands, probably not even in Europe. So these are going to be grown on where land is cheap. And yeah, it's just a little bit annoying that people are already living there and are dependent on the local environment and on the water and the resources. So this is what we try to point out in this debate. And the researchers started off by saying, we are like you, we want the same. We are, progressive, pro-environment, etc. We do all the right things, I'm vegetarian, etc. I was like, yeah, but don't you feel responsible for how your technology is going to be used? And basically the answer was no. It was very, it was very, very strange. So the good life, even I'm doing all the right things, and I know what the good life looks like. But then my technology might actually destroy somebody else's environment and livelihood for the sake of the climate problem that we have created. I mean, you see, that's really, I think, something that deserves more attention from the developers themselves too. Before they start, and that is what technology assessment is all about. Before you start, is to invite people who might know something about the eventual impacts.
Thank you. Eric, would you have any closing remarks?
Well, in the beginning, I had a few things that I forgot, and I think for time's sake, to almost end this anyway. But I think I don't know the answer to this question also, so I would like to hear some suggestions also from the audience. But we need to have a debate on who owns knowledge, who makes the rules, all those kinds of things, and who benefits. And that good life question is actually a very good question. Good life for whom? For us, or for the people that grow the plants and destroy their land or whatever, because we want to have a good life? I don't know. That's a good question. I don't have the answer to it.
Thank you. This concludes the discussion portion. We're going to have a short break, and then everyone can come back in and can ask any questions that they might have.
You can find drinks at the bar in the back.